Hello, this is Kathy, and we're starting with our Unit 2 lesson plan lecture. And so that's Chapter 2. And Chapter 2 starts on page 34, it looks like. We've already looked at the welcome.java example. And as you're reading through, you are now observing that the author dissects every line of code with you and narrative. And so I'm going over to page 41. Where we can easily edit in our editor any line of code, modifying your first program. So we're looking at, first of all, trying to position my cameras here, so sorry. Our forward slash. Those are our comment lines. Now, when we look at creating our first program, the author uses the continued comments of /* in combination, where you can document as a comment several lines of code, and you'll see that in your sample program. I prefer the // as my documentation symbolism. So now on the top of 42, we're looking at Welcome To, and again, the author narrates through this for you with the webcam or web video companion videos. So it sounds like we have a little echo here. I'm going to reduce my tone a bit. So the author, again, works his way through line by line in their web companion videos. I'd like to go to our video companion site and point out to you creating a new program. And if you haven't watched this yet, or now is a good time to watch this in review, because we're going to be doing the same actions to set up creating our first new program, because you do have a Prog 2 assignment, a program project due at the end of Chapter 2, and you will need to create your own code for that project. So watch this video, and now I'm going to spin off of that video to when we get ready to design our own program from scratch. Okay, and this program, you see the // indicating comments, and we see that color coded both in our IDE and in the code within the textbook. Public class, we always have a class name, and a class name must begin with an uppercase letter. And then our open and close braces indicating the begin and the end of class welcome to. Again, internal documentation. And then our public static void main, which is the main driver or the main starting point of any program. Within main, we have an open and close brace, and we document the end of method main with two system.out.print statements. And within, as a parameter, we're issuing a double quote for a welcome to string, just a variety of characters that are going to be quoted on output, close brace. Notice the trailing space for spacing purposes. And then system.out.println. Remember, println adds a new line, carriage return at the end of your output. So our string, again, within double quotes is Java programming, ! Close quote. So when we run this, line 9 gives us welcome to with a space. We continue on the same line with Java programming exclamation point, and the print line ln returns the carriage to the next new line of output text. Table on page 43. We use our escape sequence, escape n, for the new line, and you're seeing that to control new line placement for output. Escape T is our horizontal tab, and you can see that and use that as needed for horizontal tabbing. Our tabs are 3 spaces, horizontal 3 spaces, and \R for carriage return. \\, that's our escape character with a backslash that's used to print the backslash. So we're escaping the normal meaning of the backslash to print the backslash. And escape double quotes, we're escaping the normal meaning of double quotes to print the double quotes. So an example is system.out.println. Our string is open quotes. We're going to quote something, and we're actually going to escape the normal meaning of the double quotes to print the double quotes along with the in space quotes text, and then we're going to escape again the double quotes to print the double quotes, and then we end this string of characters with the double quotes. The next welcome message is just introducing the printf for control of formatted output. So in this example, we're going to print our string, but we're using the printf, the formatted output. Printf, where we are indicating in our formatted string that we're going to print a string, %s, a new line, %n, another string, %s, and another new line, %n. That's our string format. And now we're going to fit, we have a string welcome to for the first string, and then a new line. We pattern the next string with the next string to be printed, and then a new line. So we get welcome to, new line, Java programming exclamation point, and new line. We're on the next line of text for our output line. Printed format, printf. And then adding our integers, your next program. Again, the video code is dissected line by your author through your web companion videos. We have our opening comments, and remember to look at your beginning required comments at D2L Student Resources. Because I will be grading on your required beginning documentation, and here's an example of internal documentation, lines of code that are documented within the program itself. This is has a file name of addition.java. We're going to import the scanner so we can make use of scanner facilities, particularly in this case input scanner. Our public class addition must begin with an uppercase A and match the name of our program in this case. Public void main, public static void main is where this begins driving the program, and we're going to first ask for input from the keyboard with scanner. Our variable is input equals a new scanner system.in, so we're going to capture what's typed at the keyboard and assign it to input. We're declaring an integer number 1, number 2, and some variables. System.out.print, we're going to print a prompt to the user. Enter that first integer. And number 1 is being assigned the input integer from the keyboard. Enter the second integer as a prompt to the user. Number 2 is being assigned the input of the next integer typed at the keyboard. And then we're ready to begin processing by calculating sum and assigning it the addition of number 1 plus number 2. And our final output is system.out.printf in formatted fashion. Our parameter is string, print sum is space %d, place the integer value and then a new line. And then our parameter list sum is going to have its current integer value placed in the %d position for a decimal integer. So we're printing out sum is. We're going to fit the current integer value into the %d position, which is 117, and a new line, so we're on the next line of text on our output screen. Our arithmetic operators are discussed on page 51 in a table. So addition is represented with the operator plus. An algebraic expression from math is f plus 7, a variable plus 7. A Java expression would be f plus 7. Pretty straightforward. Subtraction, the operator is the hyphen sign. P minus C is an example in math. In Java, a similar example would be P minus C, our variable P minus current value of C's variable value. Multiplication, we use the asterisk. Algebra expression, B times M. But for Java, you do need to indicate the operator star, which is shift 8 on some keypads, I guess. Division is the / x divided by y, or in math we could have a numerator over denominator, or even the hyphen with the dot symbolism. But in Java you have to use the / to indicate the operation of division. And the remainder, if you wish to capture the integer remainder, our operator is a percent modular operator. So R mod S is in Java R divided by S and capture the integer remainder. So the integer remainder, if I have 15 mod 2, that would be 2 goes into 15 how many times? 7. With a remainder of 1, so my answer is 1. The integer remainder. Modular arithmetic, we're looking at the integer remainder. Precedence of operators. The precedence follows the same as precedence in math. Please excuse my dear Aunt Sally. Multiplication, division, and the modular have highest precedence. Addition and subtraction next, evaluated from left to right. And then our assignment operator is evaluated last. I'm recording a lecture right now. I'll have to. Bye. There's an example walkthrough of sample arithmetic and Java expressions that you can take a peek at and trace. Looking at our decision-making operators, again, the table is on page 54. And let's see, the algebra operator, the Java equality or relational operator, a sample of a Java condition, and the meaning of the Java condition. So we have our equality operators in algebra equals. our equality relational operator is equal sign in Java, and a sample condition would be x equal y. Notice there's no space. It's x space equal, no space between your equal signs, space y. The meaning is, does x equal y? We're calling for the condition of equivalency. And the not operator in Java, not equal to, we use the exclamation point, equal sign. A sample is x is not equal to y. We're asking, is that true or false? And the meaning in Java, the condition is x is not equal to y, and that will return true or false. Is x not equal to y, true or false? Not, we use the exclamation point, not equal to. Our relational operators. Here's our algebraic operators, the Java equivalent operators, and then a sample condition. In arithmetic, we use our greater than, less than, greater than or equal to, less than or equal to. In Java, our relational operators are greater than, less than, and of course we don't have a two-symboled or sub-line, so we have to type our keys separately. Greater than or equal to, no space between your operators. Less than or equal to, no space between the operators. So greater than. Sample Java condition, x is greater than y. Is that true or false? X is greater than y. We're calling the condition, is it true or false? X is less than y. X is less than y. Is that true or false? X is greater than or equal to y. X is greater than or equal to y. X is less than or equal to y. Is that true or false? In the comparison program, figure 2.15, we're expanding just a bit to test our numbers. If number 1 is equal to number 2, then we're going to print a formatted version of the integer value. Is that equal to the integer value %n? So we're going to print number 1's value equal number 2's value, and then a new line. So our number 777 is equal to 777 if it's true. If number 1 is not equal to number 2, we're going to print number 1's decimal value is not equal. The exclamation point, equal sign are quoted. Number 2's integer value is printed, and a new line. If number 1 is less than number 2, then we print number 1's current decimal value, the less than symbol as quoted, number 2's decimal value, and integer decimal value, and a new line. That is a program that you could key if you'd wish and just double check, or at least trace. I don't believe the author worked his way through line by line dissection of this code. So it'd be a good one to just check on your own. Operators. Again, our operators, multiplication, division, and the modular operator operate from left to right in associativity. The plus and minus, left to right. Less than or equal to, greater than or equal to, assigned from left to right. There are relational operators. Equality test, equal, or not equal test, left to right. And then our assignment operator, the equal sign. We calculate the right-hand side to get a result and assign that to the left-hand side of the assignment operator. So that associates right to left. At the end of each chapter is your summary. Excellent to read, review, and facts to just look through again. The self-review problems at the end of each chapter. Good to maybe challenge yourself. All the answers are given. And then your exercises. At the end of each chapter, I assign a few exercises. And now at the end of each forward chapter, we will be assigning your program assignment. And I just kind of reference that as your prog 2, your program for chapter 2. And I've set up my project directory on my C drive as Java homework. And I did call this program prog 2. That's a G. This is my prog 2 assignment. I'm getting ready to work through this project and want to be able to upload to my instructor's Dropbox for grading purposes. So it says, write an application that displays a box or oval, an arrow, and a diamond using asterisks as follows. And I think I asked you to create your initials as output. So at D2L Student Resources, there is a graph paper available for printout. So I just kind of printed out my graph paper and I sketched an equal size matrix box for my 3 initials, and I sketched, oh, there's a K, and here's an M, and here's a J, KMJ for my initials. I have 3 spaces between each blocked letter, 3 spaces between each blocked letter, and then I filled in the block with asterisks to simulate a K, to simulate the character M, and to simulate the character J. So now as I'm looking at output, I am printing, my printer prints a line at a time. So I'm going to have to quote an X, space, 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 X, space, 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 X, 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 end quote, for my first line of output. I need a new line. And for my second line of text, I'm going to quote the X's and the spaces to simulate the next line of output and a new line in order to eventually simulate the output of 3 initials, KMJ. So let's look at doing that. With NetBeans. I want to start a new project, file new project. I'm going to choose Java and Java application and next. I want to call this initials or prog2 or shapes. I want to make sure that I browse to my C:root Java homework folder, which you should have prepared by now. I'm starting this from scratch. This time I'm going to allow the check to remain to create my main class, but I need to make sure it matches my project name. So I had to delete that first parameter dot. So I have initials, initials, and I'm going to finish. Now in my initials project, I just opened my projects Explorer tab. In my initial project, I have started my source file initials.java. It's in the correct source folder. But I have a little template. And that little template at the beginning, again, I pointed out that the author uses this / asterisk and the asterisk / to indicate that this group of lines, characters, are all document comment lines. This came to me automatically with my author as my star ID. And then it's kind of built the main class and main line of code for me. So a couple things I want to do. This is my template. I'm going to, as the author demonstrated, place my open and close class main braces to open and close on a line by themselves. I'm going to begin to document as you're required to document. And I'm reading from the quality control checklist. Number 2, label programming assignments. Always add the following required beginning comments to your Java resource code. So first we have our file name, which is initials.java. Next, within comment lines, and that could just as well be the / star or / although now I have to do the / on every line. It's not commenting as we go. So multiple lines you can comment out with the / asterisk and the asterisk / individually, as your author does and I'm doing. Written by, and that'd be your name, / commenting. Written on, the date that you wrote the program, and a complete statement displaying my initials. Okay. So now I've completed the beginning documentation requirements, and again, they're found in your quality control checklist. Your quality control checklist found at D2L Student Resources. So now I want to begin typing my code within main. So it says to do code application logic here. So I'm ready to cancel that, and I want to build my output to display my 3 initials. I'm cheating just a little bit. I copied my program shapes, which I'd already had coded at one time. I have my beginning and closing and main braces. I have my beginning and ending close initials comments. And the body of my statement is performing the output lines, quoting the X's or stars that you have elected to cause the pattern for your shapes, in our case, your initials, to be displayed as output. And so I have system.out.println line, quote this line of text, which is quoting asterisks and spaces, asterisks and spaces, asterisks and spaces, and print a new line, quoting the second line of text in the asterisk space pattern, quoting the third line, and so on until I print the last pattern of quoted asterisks and spaces and a new line. So let's save our project under File, Save All, and let's try running. I have my Run button. And it ran the program successfully. And you'll see that I have a rectangular, an oval, an arrow, and a diamond shapes displayed as output using Java code to control the print out of my pattern of asterisks and spaces. Looking at my Project Explorer again, I see that initials.java is saved in the source file of my initials project. I'm just going to review that a minute. I'm going to my C drive. I have my java.homework folder. I'm going to open that up. And sure enough, here's the initials project. I'm going to open that up. These are all support files, folders needed for NetBeans. Here's my source folder. I'm going to open that up, and there is your initials.java, the actual text of your initials.java. Now, that's important to know because that is your source code. That's what Java compiles and runs in order to produce the output. And that's what I need you to upload to D2L, your .java support files, in this case initials or prog2, whatever you call your assignment. Upload that to the D2L correct Dropbox. And then as we run our program, you're also asked to upload the accompanying output. So to do that, we're going to use a screenshot. On my laptop, a screenshot is with the FN print screen combination. You may need to look up screenshot or screen capture for your device on the internet, or manuals, or you can contact the help desk at minwest.edu. They have troubleshot many different devices. So I captured the screen with my screenshot combination. I'm going to open Word. A blank document, and this is my prog 2 from chapter 2, and my output. Control V, control move, the V as in Victor, will paste your screenshot from the clipboard to the Word document, and now you can file save that and then upload that as well as your screenshot or screen capture to D2L to support your program assignment. Next, I will be reviewing with you Chapter 3. And I've been told by our IT people that since I want to use the Elmo for writing and displaying, referencing the textbook and such things, I can only have one camera active at a time with Adobe Connect. So my Elmo camera is active. You don't see me with my facial picture from my webcam. But I think we can manage with that just fine. So, Unit 2. Unit 2 is next on your list to begin interacting with the assignments, exercises, program, and chapter test from Unit 2. And thank you very much. chat with you again soon.